हमारे डेमो में हम एक मेमोरी की इमेज का एनालिसिस करेंगे। ये इमेज उस कंप्यूटर के मेमोरी की इमेज है जिसके एनालिसिस के बाद ये पता चला कि उस कंप्यूटर में क्राइडेक्स मालवेयर ने इन्फेक्ट किया था। क्राइडेक्स एक मालवेयर है जो सबसे पहले जनवरी 2012 में डिस्कवर एंड आइडेंटिफाई हुआ था। क्राइडेक्स एक बैंकिंग मालवेयर था जो कि बैंकिंग क्रेडेंशियल्स एंड अदर पर्सनल इंफॉर्मेशन, किसी भी यूजर की पर्सनल इंफॉर्मेशन एंड बैंकिंग क्रेडेंशियल्स को स्टील करता था। इन क्रेडेंशियल्स की हेल्प से वो यूजर के फाइनेंशियल रिकॉर्ड्स को एक्सेस करता था। क्राइडेक्स कैसे काम करता था? क्राइडेक्स redirect the user to a fraudulent version of the financial site as soon as the user wants to open a legal financial site, and it record the login credentials which are entered by the user. At that point, very quickly, Cridex gives the cyber criminal the ability to connect to the actual financial site from the infected computer system, and it executes fraudulent financial transactions. इस तरह से Cridex यूजर को फाइनेंशियली फ्रॉड करके उसके बैंक अकाउंट से ट्रांजैक्शन कर पाता था। So now we will move to the demo using the Volatility Framework, where we will see how the image of the memory is used to extract sensitive information which is used by the attacker during the crime. For this demo, we will be using Kali Linux, which I have installed on the virtual machine. I have installed Volatility tool on this machine. So first, open the terminal in the Volatility folder. As we said, it is a Python-based tool. So we will be using Python commands. So you can see that the folder is having a file that is cridex.vmap.
So next we will see, with the help of vol.py file, that when did this image has been captured with the help of image info plugin. So image info plugin gives us details of this file. So it is doing searching on within this image file. So as seen in the output, we can see that this image has been captured in 2012 2207 2012 and other details also. So this system was a Windows XP system with SP2 or SP3 installed. So next, for viewing the details of all the processes, we have another plugin in Volatility, that is PS List. So with help of PS List plugin, we can see what all processes were running when this attack has been taken place and this image has been captured. So you can see this PS List. So this is the process ID which we discussed earlier, and this is the parent process ID. So here we can see there are few processes which were running. So here there is a process reader_sl.exe whose PID is 1640 and whose parent's PID is 1484. So if we look at 1484, this is an explorer.exe process. So next, if we want to look at the same information in a better format with the relation between process and its parent processes, then we can use the pstree command. So here we can see like explorer.exe is a parent process and it has the child process reader_sl.exe. Now for checking the open connections on the computer at the time of taking the image, we have plugin conscan. So resulting output, we can notice that there were two connections open. One is through the IP address 41.168.5.140 and the port was 1038 and this was the local address. So now going one more step deep, like we want to see the sockets. So this process was 1484. So this connection was opened through the process 1484, that is explorer.exe. So if we want to look at the information of open sockets, then we have another plugin, sockets. So here again we can see similar kind of output, that is 1038 port was opened by the process 1484, that is explorer.exe. So now moving one step ahead, with the help of CMD line plugin, we can check all the processes and their command line arguments, that is which command that particular process has started. Like this spoolsv.exe was started with this command. So here we can see explorer.exe was started with explorer.exe, this command. So if we notice at this, we will see that reader_sl.exe, it is an executable file, but when we look at this is the program which was trying to open this particular file. So here this is an exe file, but it is opening with the Adobe, that is PDF reader. And the suspicious thing is that this Adobe reader is trying to make the connection with the other IP address, with the network connection. So this is making this is making us suspicious that there is something wrong, because this is a exe file and it is trying to open itself with a Adobe Reader and trying to make some connection also. So next, we will use the proc dump plugin. So with the help of proc dump plugin, we can particularly dump a process. So here, because we are something suspicious about the process reader_sl.exe whose PID is 1640, so we are saying volatility that dump this particular process, and this option, that is --dump.dir dot, it means dump this in this particular file itself, in this particular folder itself, sorry. So proc dump is a plugin. So you can see this plugin has given the output this reader_exe file, and if we see the this particular with the help of ls command, we can now see that this folder is having file executable.1640.exe. So now what we will do, we will submit, to confirm our doubt, we can submit this file to any of the tool, any of the online tool which is for checking the malicious script, malicious APKs or malicious EXEs. So here we have submitted this file to the virus total engine, and you can see that as a result that 29 out of 66 vendors flagged this file as malicious file. So again, this is making us more suspicious. So now going one step ahead and coming back to the command line, now let us dump the memory of this process. So when we dump, with the help of MEM dump plugin, the memory of this particular process, so you can see it is dumping all the contents of this process within a file that is 1640.dmp. So let us check with the help of ls command, and we can see that there is one new file created, that is 1640.dmp. So now if we will look at, so this is a dump file, fine. So with the help of strings command, we can look at the strings present in this dump. So we can see the strings present in this. So you can see that there are some bank domains. These are the online, this e-banking. So there are many banking domains which are hard coded in this particular dump of this process. So you can notice that there are a lot of banking websites that this particular process is trying to connect to. See. So now what we can do, because we want to confirm whether this process was trying to connect to the IP address that we have seen earlier, that is 41.168.5.140. Yes, we can see that this particular IP address is hard coded inside the process dump file. It means we are now sure that this 1640 is the process which is trying to connect to this IP address. Now, going one step ahead, we can, as discussed in the theory, some malwares also try to change the registries. So, we can print the registry values with the help of print key plugin. So, there are multiple registries which can be checked. Here, we are checking the run registry. So this is the path of that registry. So run registry gives us this command gives us the information of run keys and their edit times. Run keys execute each and every time user login. So here you can see that this is the name of the registry. These are the values, key name, and then subkeys. Subkeys, values, subkeys, values. So here we can notice that almost all registries update time is 2011. You can see here. But there is one registry that is anti-user.dat, and the last update time of this registry is 2012-22/7. That is the date on which this image has been captured. And we can see the value of this registry. So this registry has set up this value, that is, there is some exe file name is set to this registry. So it means whenever the system boots and user login, this exe file will be executed. So now to get confirmed that whether this exe file is copied by the particular virus or particular malware or not. So what we can do, we can copy this and we can check whether this particular string is present inside the dump of that process. Yes, here we can see that this exe file name is hard coded as a string inside the 1640.dmp process.
So after the analysis of this memory dump, we can summarize our findings as follows. हम बोल सकते हैं कि सिस्टम में एक ऑड कुछ अलग सा प्रोसेस एग्जिस्ट करता है. इस प्रोसेस का नाम reader_sl.exe है और इसका प्रोसेस आईडी 1640 है. साथ ही इसका पेरेंट प्रोसेस एक्सप्लोरर प्रोसेस है और उसका पीआईडी 1484 है. इट मींस ये ऑड प्रोसेस ब्राउजर के थ्रू स्टार्ट हुआ है. ब्राउजर के थ्रू स्टार्ट हुए प्रोसेसेस नॉर्मली सस्पिशियस होते हैं. इस प्रोसेस ने नेटवर्क कनेक्शन एस्टेब्लिश किया था, जो कि अभी तक भी ओपन था, और ये नेटवर्क कनेक्शन जिस आईपी एड्रेस से हुआ था वो है 41.168.5.140। साथ ही ये प्रोसेस स्पाई प्रोसेस की तरह भी काम करता है, जो ये मॉनिटर करता रहता है कि यूजर कब बैंकिंग वेबसाइट्स को या बैंकिंग डोमेन्स को विजिट करता है। इसके अलावा जब हमने इस प्रोसेस की एग्जीक्यूटेबल्स को डिफरेंट सैंडबॉक्सिंग वेबसाइट या मालवेयर डिटेक्शन वेबसाइट्स पे सबमिट किया, तो इन वेबसाइट्स ने इसे मैलिशियस ट्रोजन डिटेक्ट किया। इन्वेस्टिगेशन में यह भी आइडेंटिफाई हुआ कि इस मालवेयर ने विंडोज की रजिस्ट्री में रिसेंटली चेंजेस किया है और रजिस्ट्रीज के पाथ को मालवेयर ने अपनी एग्जीक्यूटेबल के पाथ से सेट किया है। So this was a simple demo, and more analysis can be done with help of memory forensic investigation approaches. With this sort of analysis, we can conclude, we can derive what was the crime, when did it happen, how it happened, who was responsible for this crime. So in the end, we can summarize it like digital forensic is the preservation, identification, extraction, and documentation of computer evidences which can be used in the court of law. Cyber criminals are continuously developing new ways to hide themselves. Therefore, it is hard to restrict cyber crimes completely. Awareness, prevention is much better than post-investigation of cybercrime. And for this, understanding of various risks of social engineering and common social engineering scams is necessary by each individual person. Along with this, all the organization should include proper security solutions to defend against various types of attacks. Thank you, learners.